Good morning everyone. Today we're going to explore about the dawn of modern mathematics. The 17th century spread of knowledge in the year of 1600. William Gilbert published the De Magnet marks the beginning of modern physical science based on experimentation. This De Magnet is a scientific work of William Gilbert. In year 1614, John Napier published Mirifici Logarithmorum Canonis Descriptio, introduces logarithms, a major advancement in arithmetic and astronomy. This logarithm is like an exponent, the power of which a number must be raised in order to get some other number. Then in year 1619, Johannes Kepler formulates the laws of terrestrial motion based on elliptical orbits rather than Aristotle's ideas circle. Then in year 1628, William Harvey describes the blood circulations, demonstrates the movement of blood through arteries and veins via the heart and lungs. Then in year 1628, Descartes published La Geometry, introduced analytical geometry, marrying algebraic and geometry. Pierre de Fermat and René Descartes simultaneously developed analytical geometry dependently. This analytical geometry, the study of geometric shape using algebraic equation. Then in year of 1661, Robert Boyle published The Skeptical Chemist, lays the foundation for modern chemistry. Then in year 1665, Robert Hooke publishes Micrographia, first major work on microscopic observation. Then in year 1670, Pascal and Fermat corresponds or probability theory contribute to the foundations of mathematical probability. Then in year 1687, Isaac Newton publishes Principia Mathematica, culmination of 17th century mathematical and physical truth. Second subtopic is Galileo's telescopic observations. In year 1564 to 1584, Galilei is born in Pisa, Italy. Enrolls at the University of Pisa as a medical student. And Galileo make his first scientific discovery, the isochronism of pendulum, by observing a swinging chandelier. In year 1585, leaves the University without a degree to pursue mathematics inspired by a lecturer, Euclid, by Ostilio Ricci. This year, she lives in University of Pisa. Then in year 1585 to 1589, studies Greek geometry and mechanical, supports himself by teaching mathematics. Then in year 1589, at the age of 25, appointed a lecturer at the University of Pisa, and performed his famous learning tower of Pisa experiments, demonstrating that objects of different width fall at the same rate. Then in year 1592, leave Pisa and become professor of mathematics at the University of Padua, where he remains for 18 years, construct his own telescope, begins systematic astronomical observations, becomes the first study the sky with a telescope, and published findings. In this year, he studies he is a professor of University of Padua that he invented the telescope in this year. Then in year 1609 to 1610, discovers of 4 moons of Jupiter, Europa, Ganymede, Callisto, a major blue to geocentrism, publishes finding in a 29-page booklet titled The Sidereus Nucleus, the Starry Messenger. My third subtopic is about the beginning of modern notation by Francois Vita. In year 1540, Francois Vita is born in Fontenay-le-Comte, France. In year 1570 to 1580, he begins work as a private comes tutor and later a lawyer and royal counselor. In year 1591, he publishes the Art Analytic, Introduction to the Art of Analysis. This is the first systematic use of letters to represent known and unknown quantities in algebra. He uses vowels for unknowns and consonants for known quantities, a major leap in symbolic notation. In this year, he used the systematic letters like vowels, consonants, vowels for unknown, consonants for known. Then, in year 1593 to 1595, he published the Supplementum Geometri, where he solved geometric problems algebraically, furthering the connection between algebra and geometry. Then, in year 1590, works in cryptography for the French court and deciphers Spanish codes, earning fame in both science and politics. Then, in year 1603, Vita dies in Paris, France. Now, my fourth subtopic is all about the decimal fraction of Simon Stevin. In year 1648, Simon Stevin is born in Bruges in Spanish Netherlands, now in Belgium. Then, in years 1685, published the Tinde, the 10th. This groundbreaking work introduced the decimal fraction as a practical and systematic advocates for the use of decimal in everyday arithmetic. Uses a unique system of indices, not modern decimal points, but these ideas laid the groundwork of modern decimal notation. Then in year 1580 to 1590, he became the mathematician and engineer for the Prince Maurice of Nassau. Works on practical application of math in hydraulics, fortifications, and navigations. Then, in year 1590, he writes various treatises integrating decimals into trigonometry, geometry, and algebra. Then in year 1600, he helps establish the mathematics as the essential to science and engineering in Dutch military and civil service. Then in year 1620, Simon Stevin dies in the Hague. Now, my fifth subtopic is about the Napier's inventions of logarithms. In year 1980, John Napier is born in Edinburgh, Scotland. He grows up in a noble Scottish family and receives an education in mathematics, astronomy, and theology. Then, in year 1981, Napier studies as the contemplates problem in astronomy and arithmetic, especially those involving complex time-consuming calculations. He becomes increasingly interested in simplifying multiplication and division, particularly for astronomers. Then, in year 2011, he begins working on the concept that he become logarithms, exploring how repeated multiplication powers relates the arithmetic's addition. He seeks as a method to convert multiplication and division into addition and subtraction. And this year, he discovers the power or the exponent. Then in year 2015, publication of Merifici Logarithmium Canonis Descriptio, the descriptions of the wonderful canon of logarithms. Napier publishes the first book of logarithms. He presents the logarithmic table. Then in year 2016, Henry Bridge, an English mathematician, visits the Napier's Edinburgh. Brigg and Napier collaborate on refining the logarithmic system. D agrees on adjusting Napier's original logarithms to base 10, which would be later be known as a common Briggshian logarithms. Then in year he presents the introduced Napier's bones, a manually operated calculating device based on rods and multiplication tables. John Napier dies. His ideas live on the continue to influence mathematics, science, and engineering. Bridge published extended tables to common logarithms based on Napier's work. My sixth subtopics is all about the astronomical discoveries of Brahe and Kepler. In year 1563, Tycho noticed significant discrepancies in existing astronomical tables. Alphonsine and Copernican, sparking his desire for more accurate observation. Then in year 1571, he discovered a new star in the constellation Cassiopeia, proved that the heaven could change. Contradiction, Aristotle believed in an unchanging celestial realm. Then, in year 1577, included that the comet was located beyond the moon by measuring its parallax, contradicting the belief that comets were atmospheric phenomena. Then, in year 1576 to 1597, contradicted the most accurate naked eye astronomical observation before the invention of telescope. Then in 1590, a hybrid cosmological model, Earth the center of the sun, revolving around Earth and other planets orbiting the sun, a compromise between Ptolemaic and Copernican models. Then in year 1600, worked as a Brahe's assistant, gained access to Brahe's detailed planetary observations, especially of Mars. Okay, now, in year 1601, Kepler succeeded him as an imperial mathematician and inherited his observation data. Then in year 1604, he published the Astronomy Pars Optica, made by important contributions to optics and behaviors of light in astronomical instrument. Then in year 1604, observed supernova. In 1604, Kepler's supernova, the last supernova visible to the naked eye in our galaxy. In 1609, introduced the Kepler first and second laws. The first law of Kepler, the planet orbit the sun in ellipses, with the sun at one focus. Then in the second law, planets sweep out equal areas in equal times. Then, in year 1619, he introduced Kepler's third law. The square of a planet's orbit period is proportional to the cube of its semi-major axis distance from the sun. Then, in year 627, the star catalog and planetary tables based on Tycho's data and Kepler laws far more accurate than predecessors.